All right, for this second one, we have that a farmer owns a field in the shape of a triangle ABC, such that AB right here is 650, AC is 1005, and BC is 1225. All of these in meters. So careful with your units. These are all in meters. And so for part A, they ask us to find the size of ACB. Now, would they write it like this? Find the size of ACB, and they put a little bit of thing on top of the C. That makes reference to an angle, okay? And so that little symbol there is asking us, okay, you need to find this angle here, all right? So we are looking for the angle of C, basically, that is between A and B. Now, whenever you are working with triangles in particulars, you should be thinking in trigonometry, okay? Trigonometry. And there's a lot of different tools we can use here. Mainly in our formula booklet, we have the sine rule and the cosine rule. Okay, these are the two rules we have, and they're going to come into play shortly. So let's go ahead and pull up our formula booklet. So here it is. Da, da, da. I'm going to do Control F, cosine rule, and see what's going on. See? So in our same formula booklet, we have sine rule, cosine rule, and area of a triangle. Okay? And the main thing that people sort of like miss when they're studying this is understanding well the formula. Okay? If you understand your formula, you understand your tools. If you understand your tools, you have a full grasp of your formula booklet, and the day of the test, you walk in and you have a pen, a pencil, an eraser, your mind, and the formula booklet. Okay, so you gotta get familiar with it. Let's see how this works. All right. Any big letter, I'm actually gonna write this over here. So big letter equals, whoops, how the hell do you make it equals? Big letter equals angle. Little letter equals side, okay, or distance, whatever. See? So if I go ahead and draw, say, a triangle like this, and I choose that this is wait, sorry, hold up, that this is angle A, then that means I have side little a. If I say that this is angle B, then I have side little b. If I say that this is angle C, that means I have side little c on the other end. All right, so that is why there's big letters and little letters in this case. And you will notice that this sine always goes with an angle, okay? Sine with cosine, which makes sense, see? But basically, as long as you have this in mind, the big letters are angles and little letters are side, you should be able to navigate these formulas without an issue. Also, keep in mind that A, B, and C is all like arbitrary. Like you choose what's A, you choose what B, you choose what's C. So in this case, we have three sides and we're looking for one angle, okay? The sine rule you will see has sort of like four parts to it. See what I mean by four parts? Usually you work it like this. You have one angle, sorry, you have one side, a second side, one angle, a second angle. So if you have two pairs, you're good to go. In this case, I don't have pairs anywhere, see? Because I do have this distance, but I do not have that angle. I do have this distance, but I do not have that angle. And I do have this distance, but I do not have that angle, so I have no pair. As long as you have at least one pair, and you sort of have like 3 out of 4, that means like this one, and this one, but not the last one, then you can solve it. But in this case, we have no pairs. So for sine rule, even though we're not going to use it, it's good to have in mind, it works in pairs. Okay, that's like the big thing, right? Cosine rule, like if the sine rule doesn't work, cosine rule has to work. So like if you don't have pairs, cosine rule is probably what you have to use. Cosine rule is a little more funky, but let's see what happens. See? So in this case, as we said, we have a bunch of sides, but no angles, and we're trying to find one angle. See? And so if you notice here, we have one of the sides, right, with C, another side with A, another side with B. So here it is asking for all the sides. A and B repeats itself, and only one angle. Ah, so I'm looking for just one angle. Also, there are two cosine rules or formulas or whatever. We have the one on the left, we have the one on the right. They are quite literally the same. Okay, there it just moves some terms around. It's the same formula. In this case, I'm gonna use the one on the right, just because it has the angle alone on one side and it's easier to navigate. So I'm gonna write out that formula over on this side. Okay, we said it's cosine C equals a squared plus b squared minus c squared divided by 2ab. All right, so again, big letter is angle, little letter is distance. And so here, since I said that c and a and b is completely arbitrary, you have to define it yourself. Now in this case, it aligns perfectly. Okay, but that doesn't always happen. What do I mean by this? My c, in this case, is exactly the angle I'm trying to find that's alone. Okay, so that's very convenient for me. But my c, quote unquote, could have been this one. Okay, and then I'd have to be consistent in my formula. Why does this matter? Well, because you will notice that the angle you're trying to find, its distance has to be negative. The other two, you can switch them around. I mean, the positive, these two are being multiplied, it doesn't matter. But you do have to capitalize on which angle you're trying to find, and from there, it goes on smoothly. All right, so that was a lot of explanations of how this works, but you will see that once you're familiar with the tools you have, the rest goes by really, really fast. Okay, and the main things I had to explain were what are the big letters, what are the little letters, and to make sure you're consistent with your formula. See? So I'm going to do cosine C equals a squared, which is anything but little c. So I'm going to say that a squared is going to be this guy here. See? So 1, 2, 2, 5. Big A, little a, ¿cierto? Plus b squared, big B, little b, minus c squared, this guy here, of course, right? Divided by 2 times 1225 times 1005. All right, awesome. So what you do from here, actually, and I missed opening this up. Give me 1 second. So what you do from this step is that you have to get c alone. See? So I'm going to have cosine c on the left side still, and everything on the right side I'm going to be plugging in. Okay? So bear with me for a moment. Da, da, da. All right, so everything on the right side is that. It is 0.8480. And a lot of people here just say, ah, this is the answer. See? And so that would be a mistake because you still don't have your angle alone. Remember that your angle is C. It is not cosine C, it is just C. And so if you want to get C alone, you have to do cosine inverse. So you do cosine inverse to both sides. I end up with cosine inverse of this, and that is my answer. So cosine inverse of this, bada bing bada boom, my angle C, or for part A basically, is going to be 31.9980, same as calling it 32. Now I'm going to take a moment and explain why we did cosine inverse, because I know a lot of people are confused by that. So in this step, we had cosine C equals 0.848, right? And so since we want to get this guy alone, we need to do the inverse, see? So this is no different than, I don't know, say you have 2x equals 4, see? And so if you want to get x alone here, you need to see what is affecting x. So x is being affected by 2. In which way? By being multiplied. What is the inverse of a multiplication? The inverse of multiplication is dividing. So you divide to get x alone. Divide to both sides, of course. You end up with x equals 2. All right, this on the left side is no different. What is the inverse of cosine? It's cosine inverse. So once you do cosine inverse on this side, all it really does is get rid of the cos, and you stay with the angle inside. And that's how we got 32. All right, awesome. So that is a pretty thorough explanation, to be honest, of part A. But there it is. For part B, they go on and tell us that The local town is planning to build a highway that will intersect the borders of the field at points D and E, where DC is 210 and CED is 100. Most of these things are already in the diagram as it is shown below. See? Awesome puzzle. So now we need to find DE. And so here what I like to do, especially if there's a new triangle that gets involved, is to draw it out. And so DE, when it's placed like this, makes reference to a distance. See, it makes reference to the side. It's this thing that's super mega bolded. All right? And so that triangle there, I'm going to draw it out. We have C, D, and E. And basically, I have to analyze what information I have. So I have 210 over here. I have the angle 100. And there's one more thing I have, see? Which, by the way, has to do with part A. See, part B usually needs things from part A. From part A, I got that angle C was 32, so that means that this guy here is 32. That also means that this guy here is 180 minus 100 minus 32. Why? Because there's 180 degrees in a triangle, so I subtract the other two, and I end up with, God, how much is this? I can't math right now. It's 48. See, so that angle is 48. All right, point is, again, same approach. You're trying to find DE. So I'm trying to find one of the sides. It's this guy here. The first thing you do is you open up the formula booklet and you go from top to bottom. See? And there's only two options, so it's not that complicated. You want to prioritize using sine rule. If that doesn't work, cosine rule is going to be your savior. See? How did sine rule work again? What was the most important thing? It works in pairs. So do I have pairs here? Yes. I have big E, which is this angle 100, paired with the little e. Oh, interesting. And I have big C paired with the side I'm trying to find. So sine rule looks like this. We have little letter on top, big letter on the bottom with sine, and then the same thing on the other side. See? So this is no different. And once you get familiar with the formula booklet, this is how you start seeing it. You have distance 1 on the top, angle 1 on the bottom, distance 2 on the top, and angle 2 on the bottom. And so once you start looking at it like that, boom, it comes to your mind immediately. See? So in this case, my distance 1, we said was 210. Its angle 1, we said was 100. So we have sine 100. The other side, the distance we're trying to find, which we're just going to call DE, ¿cierto? And its corresponding angle from part A is 32. So sine 32. So I'm going to go ahead and call DEX just because it's more friendly to write it out. So I'm going to put X here. This right here is going to be X. And I need to get X alone. So from this step, I can go ahead and cross multiply. So I have X times sine 100 equals 210 times sine 32. I still need to get X alone. X is being affected by sine 100. It's being multiplied. So I divide by sine 100 on both sides. And I end up with X equals 210 times sine 32 divided by sine 100. Awesome. I'm going to take one moment here and just point out why we don't use sine inverse here. The reason you don't use sine inverse in here is because sine inverse is only if you want to get the thing that's inside. So earlier we used cosine inverse because we were looking for the angle that's inside. See? In this case, X is being affected by sine 100, but it's just being multiplied by sine 100. Sine 100 is an actual number. You can go like this, sine 100, boom, it's an actual number, all right? So I'm basically dividing by 0.98 on this step here, see? But yeah, I just wanted to point out when and why you use sine inverse. More importantly, why. If you understand why in anything, it enters your head a lot more, see? So anyway, X is that. I'm going to go ahead and put it into my calculator, just so that you guys trust me. We have 210 times sine 32 divided by sine 100. That is that. We have that for part B. DE is going to be 112.9937. We also notice that this is worth 3 points. And because it is worth 3 points, we are probably missing something. We are missing our units. This is in meters. Careful. You can also write it out into significant figures, all the good stuff. You end up with 113. All right. Later on, they tell us that the town wishes to build a car park here. They ask the farmer to exchange the part of the field represented by angle DCE, and in return, the farmer will get a triangle of area ADF. So this triangle up here, right? So he's gonna lose CDE and get the thing in purple. ¿Vale? Where F lies on the same line as D and E, as shown in the diagram above, blah blah blah. And to find the area of triangle DCE. Now, when you are trying to find the area of any sort of triangle, you have two tools. Okay, so area of triangle. Your first option, which is the classic, is you do base times height divided by 2. The complicated thing here is that it's not always evident how to get your height. For example, in angle CDE, your height is like that. So you would have to find that, which is kind of hard, right? Anyways, that's your first tool. It's the classic. You know, it's what we're used to. It's base times height divided by 2. It always works, blah, blah. But there is another one, which is like the trig version, all right? So as we said earlier, we have area of triangle. It's right there. It is that your area equals, right? Big A in this case is for area, all right? So that's a little bit confusing. Big A here in this case is for area. Your area is going to be 1/2 AB sine C. And so I know that looks a little bit weird, but let's take a moment and draw a triangle. See? So we have whatever. I'm just gonna call this big A, big B, little b, big C, little c. So this is stuff we're used to. So if we highlight a little bit, do I have a highlighter? Oh, I do. So little a, little b, sides. ¿Cierto? So boom and boom. Big C. Where's big C? It is here. Notice that big C is in between the two sides. And so whatever you define to be A, whatever you define to be B, you need the angle that is in between them in order to make this work. So if I'm looking at the area of triangle DCE, you need to see, okay, I could have this angle. Sorry, hold up. You need to say like, I have this side, and I need that angle. So that's one option, right? You can also say, I have this side and this side with D, and I have that angle. And then you can use the formula. And your last option is, I have this side, and I have that angle. Okay? So out of those three options, you might have noticed already which one is the most convenient one. Again, part C needs something from part B needs something from part A, etc. In this case, I have this side here, 210. I have this side here from part B, and I have this angle here, which I got it by doing the 180 minus blah blah from earlier. See, this 48 right there. So I'm just going to use that. So my little a is going to be 210. My little b, again, it's arbitrary, is going to be the x value from earlier, which we said was 113. So 113. And my sine C, right, the big C I should mention, so this C here is going to be 48. All right? So again, it's arbitrary. You choose how you define it. But once you get familiar with this tool, you notice that A, you need two sides and the angle in between, period. All right, there's a couple ways to remember it. That's the way I like to remember it. I'm a very visual guy, so I hope the highlighting thing helped. But yeah, that's all. Awesome. So I'm going to go ahead and use that formula. See? So we're going to have 1/2 times A, times little a we said was 210. A little b we said was 113. Big C we said was 48. So the area of my triangle is going to be this. This always works. You just have to be consistent with what you're plugging in. See? And the way you plug it in and everything. So I'm going to go to my calculator. We have 1/2 times 210 times 113 times sine 48. Okay, that's a pretty big number. We end up with 8,817.18, which is pretty much the same as putting 8,820 meters. Now meters what? Meters squared. Why is it squared? Because we're talking about an area. Meters to the power of 1, which is usually something you don't even write, is going to be a distance. Meters squared is going to make reference to an area. Meters cubed is going to make reference to a volume. All right, awesome. So that is why you put those little numbers up there in the first place. That is for part C. All right, and last but not least, we have probably one of the most creative questions for this paper. We have that we need to estimate DF, and that I may assume that the highway has a width of 0. All right, what the hell is going on? DF is the guy that's up here. Right, I'm gonna erase some of this because there's a lot of shit going on. So we need to find this distance here that I just drew in red. More than find, we need to estimate it. See? And so there's a couple assumptions we have to make in order to make this work. So essentially, if we're looking at DF, we're looking at that triangle there. See, so I'm going to go ahead and draw it out. I'm going to try to make it a little more artsy. So we have D, we have F, we have A. So we need to ask ourselves, what the hell do we know about this triangle? Okay? So what we know is that originally CA was 1,005, and here there's 210. So that means that DA, ¿cierto?, is going to be 1,005 minus 210. Okay? And that is, I feel like it's really easy, but I just can't think right now. So I'm going to use my calculator. 795. Okay? So that's the first thing. That side right there is 795. I'm going to draw it up there because I am tedious for my stuff. So that is 795. Okay? What else do we know? We know this angle. Okay? This is like a parallel lines property. This angle is equal to this angle, much like this angle is equal to that angle. Okay? And so way earlier, we found that that was 48. So here we have 48. All right, and we need to find x, or df. See? So we need to find x, or estimate it. All right, so honestly, there's not too much you can do here, and you have to get very creative with it. All right? The biggest thing here, and this is an exercise that I don't like too much because it's a very specific hint. But there's one line here in this whole paragraph. That is one kind of cool thing about the IB. Like the stuff they mention in these paragraphs, like it's usually all used. It's not common that they put something that doesn't help you. Okay. So notice that for this deal where they make a car park, and they take some of this guy's farm, in return, the farmer will get a triangle of equal area ADF. So that right there is humongous. Equal area ADF. So this area here, whoops, didn't let me draw it. Hold up. Basically, this area that I'm going to draw in, say, brown right now, is the same area that is in brown over here. So, if we're talking about areas, that can be useful. We said that areas has two versions. See, we have base same side divided by 2, and the trigonometry one. Right? In this case, we're going to prioritize the trigonometry one. And so if I use this equation like right off the bat and just kind of see what happens, right? We note that the area was 8,820. See? 1/2, and here I need to put two sides. See? So if one of the sides we're looking for is here, this x, ¿cierto? I'm going to go ahead and put x. The one that's adjacent to it is the 795. And the angle in between is the 48 right here. See? Sine 48. So again, that is very hard to notice, okay? And so the biggest hint I can give you is like, dude, anything the IB gives you in these paragraphs is probably going to get used. So highlight the buzzwords. In this case, I should have highlighted earlier, to be honest. Equal area. All right. That comes in clutch. And also the other hint you can use, which is actually a prime example in this exercise, is that part B needs something from part A, part C needs something from part B, and part D needs something from part C. And so if you found the area of a triangle, you probably have to use that for part D. It's not always the case, but in this scenario, it came in clutch. Okay. So I have this set up, and now I need to get x alone. See? So it's going to look a little bit messy, but technically x is going to be equal to 8820 times 2. So that's this guy here being multiplied, divided by 795. So that's this guy being divided again by sine 48. So that's this guy being divided. So all of that done makes me get x alone, as you see on the left side. So x is going to be equal to this. All right. So we take out our calculator. Bada bim, bada boom. We pull up that thing. Whoops. We put 8820 times 2 divided by 795 times sine 48. Ta-da! You end up with 29. Okay. Point. Whoops. 85. 7. 8. Which is roughly the same as 29.8. So that is for part D. Some of you, if you're doing it along with me on the side, might have gotten a different number for this guy here. See? Or you might even notice that the formula booklet has it. I mean, sorry, the answer key has it different. The answer key has it on 29.8473, and we have 29.85. So there's a slight difference there. That difference arises because we used the estimated value from part C. We used 8820 instead of 8817. All right, and so that small difference is the kind of thing that makes you, you know, have a slightly different answer or whatever. But as long as you're consistent, you get full credit. Do not worry about that. I did want to mention it because I'm sure someone out there is facing that issue. Anyways, that is number 2.